But before I crack on, I need to quickly tell you about STEM subjects. Have you heard that phrase before? STEM subjects? It stands for science, technology, engineering, and maths. And I decided to choose a couple of images, an image for each one of these things. And for science, I chose someone explaining something to someone else. Science, the word means knowledge and understanding. And in order to know something, you quite often have to ask questions and maybe come up with an idea and then maybe test that idea. And that's what experiments are all about. And it's useless inventing something new, a new piece of knowledge, if you don't then share it with people. And so it's really important to write things down in a way that other people understand. Technology is about using that information, possibly from someone else, to make the world a better place for us. And I put a bag here because imagine the world before bags. You'd have to carry everything in your arms. It would be really tricky. But when somebody invented the bag, suddenly we could carry things in ways that we couldn't before, very carefully, or maybe you could chill things, keep them cool, and you can carry more things than before. But however the bag works depends on what you want it to do, and that will decide which materials you will use to make it as well. And it would be really, really boring to make bags all day, every day, exactly the same way. So we have engineering, we have machinery that makes things for us. So with a bag making machine, we can churn out millions and millions of bags exactly the way we want them to be, without having to spend lots of time making them ourselves. Now, in order for scientists to talk to people to make technology, and for them also to talk to people who do engineering, we need maths, because we need to explain amounts of things and numbers, and so maths is the science of amounts. And for all these to fit together, we need loads and loads of people in the UK. So I am one of many, many STEM professionals, people who work all day, every day in a STEM subject. There are about 5 million of them in the UK. So my name is Andrew, and last year I got a medal from the Queen for all of the STEM stuff I've done, which was rather splendid. And she's great. She's an absolutely brilliant person. What did I want to do when I was 10? I had no idea what I wanted to do, but I knew I liked Lego, Meccano, and Locktronics. Locktronics is a sort of electronic kit, and my dad brought it home from his work. He was a science teacher, for me to play with each weekend, and I loved it. And, you know, really it was all about building things. So 2 fun facts about me. I was on BBC's Newsround with a futuristic car. There's the futuristic car. And there's a shot they didn't use of us drinking water from the exhaust pipe. I'll explain a little bit more about this car later on. It really is quite brilliant. I also built a machine to measure how shiny cats are. Yes, you heard that right. I built a cat shininess measuring machine. But back to your age, what did I like when I was at primary school? I liked school plays, although I didn't have a very good memory. I still haven't, so I wasn't very good at remembering the lines. I also liked Doctor Who and chocolate. And what were my best school subjects? Art and design and technology, and I kept winning the school art prize, whether I was at primary school or secondary school. I was really very good at art, and I could have ended up being an artist, but I changed my mind and went for science. So what is my job like where I work? I work at a place called the National Physical Laboratory. That's our logo up there in the top right hand corner. In short, it's known as NPL. And there I do colour measurement science. So my job, what I do every day, is, well, to build machines to measure colour, but also light and invisible ultraviolet as well. So I build machines that see these things effectively. And we also do experiments. For example, experiments on how people see light and colour. And this is my boss Julie's amazing how people see colour machine. And she's actually sitting there looking down an eyepiece, and then she's doing an experiment on herself to see how she can see colour. We ask people to match colours that they can see down this eyepiece. And then I use Julie's results to help me measure the colours of things. So, for example, phone screens and signs TVs, computers, paper, paint, plastic, food, and light bulbs. And this is really, really useful stuff for at home and for in the shops, at school. Everything that we look at has got colour, really, and we can use that colour in all sorts of different ways. So what we do really has an enormous way of helping society. And I can travel the world telling people about the work that we do. And I guess you're all too young to remember the dress. There's a picture here of this dress that someone sent on social media. I think it was Facebook. And some people, when they saw this dress image, they said that it was made of white and gold. And other people, when they saw it, said it was made of black and blue. And people argued really strongly about what it was that they could actually see. And as a vision scientist, as a colour expert, I was drawn upon to explain what I thought was going on here. And I was quoted in the newspaper and on radio and things like that. So what are the best bits of my job? Well, getting machines to work that help people. And I think that's really why I ended up as a scientist rather than an artist. I thought I could probably help more people improve the quality of their lives better by doing science than by doing art. I'm sure that artists can cheer people up and make people think, but I really felt that this was the better way for me to go. And where I work, there are lots and lots of enthusiastic people, all who love science, so I really get to feel I'm in the right area. And I can talk about my work, and I quite enjoy doing that, which is why I'm talking to you now. And I talk to people about my work at science fairs, conferences. I've been on TV and radio and in the papers. And I think one of the best bits of the job, perhaps, is that I can drive a car of the future. So I've got a little video. So this is a car that NPL people can use.
This car is very different because of the fuel it uses. It's powered by hydrogen. The only pollution from the exhaust is water vapour. With zero emissions at point of use, I don't have to pay road tax and congestion charges. Cars like this are going to be part of a carbon-free energy future. Just recently, the government has decided that in 15 years' time, you can only have cars like this or electric cars. It doesn't burn the fuel. Instead, hydrogen from the fuel tank combines with oxygen from the air to make water and electricity to drive the engine. And all you get is water. Plain water coming out of the exhaust pipe. You can actually drink it.
Thank you very much. So, as employees, we are allowed to borrow this car and drive it around. And if I was at your school today, I would probably have driven to your school in this car and we could have had a look at it. It's great. It really is the car of the future. And in a funny way, we are driving the future in the work that we do. So what are the challenges? Whenever you do a job, there are always tricky things that can annoy you. So, for example, I get about 200 emails a day, and sometimes I just think these are just interrupting the things that I'm trying to do, but actually quite a lot of these people want things from me and they benefit from what I'm telling them. So it's the job, actually. I might get to the end of the day and I've only answered emails, but I've done something really useful for people. But they can sometimes interrupt me when I'm trying to do something else. Broken machinery is obviously always a problem whenever you're doing science or engineering or Lego. And trying to fix it, sometimes it can really frustrate us when things don't work properly. And generally things take longer than you thought they always were going to. But you know, these three things here, on the whole, would be with you whatever job you do. They're not just for scientists and engineers. So what I am doing, I'm very happy with what I do. So what is my workplace like? Well, this is the outside of the building where I work, NPL. And we've got several sites around the UK, but this is our largest one, which is quite close to Hampton Court. And it's got about 400 separate laboratories inside. They all look very, very different, and they all contain amazing people doing brilliant science. So here's my friend Claire with her amazing medical imaging machine. and she's doing what seems to be some experiments on a fish tank, but actually she's measuring the power of this machine, and she's measuring how much energy is coming out of it, because not only does it do imaging, but it also helps with the treatment of cancer. So really important, useful stuff being done here, and it's a measurement science thing. Here we have Teresa with a light measuring sphere. You put the light bulb inside this big metal sphere, you close the door, which at the moment looks as though it's a set of steps, but the whole thing swings around, and then you can do a measurement inside to tell you the total amount of light coming out of a light bulb, which is really important. And I've got lots of friends working in the area of light measurement. Here are another pair of them. This is Helen and Steve, and they're measuring how bright this light bulb is in a particular direction. And you can see they're very carefully aligning the thing so that it's a particular distance. They need to know the distance really accurately to get a good measurement on how bright the light source is. So I said fairly early on that I was a STEM professional. So which STEM topics do I use in my work? Well, all of them. And if you were to look into how I make things to measure colour, well, it's quite a good way of demonstrating it all. Science, well, I do experiments to find out how people see colour. I then use that information to help design machines and information technology to copy what nature does. And there's a really good example if you've got Apple devices called Color Say. It looks like that, Color Say. And you kind of point your phone or your iPad in the direction of an object, and it tells you in words, it speaks out loud what the colours are, which is great fun. But what's going on inside there is literally what happens inside our eyes and our heads every day. It's amazing. And engineering. Well, I have to make sure that things keep working the way that they're supposed to, which is why I have to communicate colour all the time and get machines to work the way that they do. And to communicate, I need maths, and I use maths every day, every single day. For example, this map here is something to do with how I talk to other people about the colours of traffic lights. Well, we plot colours on charts. This is a colour chart. It contains all the colours that exist, sort of. And there have been some experiments done on people to see which are the best colours to do traffic lights with, to make traffic lights with. And these are the colours that people have chosen. They're actually been chosen so that people who are colourblind can tell these colours apart. But can you see on the big chart, we've got areas marked in white, and that inside those areas are the colours that traffic lights must be. So there's a small range of reds, a slightly larger range of ambers that you're allowed to use, and quite a large range of greens. They're actually a greeny blue. And to plot these things, you use numbers. Can you see the numbers along the bottom and along the side? So numbers are used to describe colours. Let's do a couple of experiments right now. Are you up for doing some colour experiments? We've got two here, and they're fun. They really are quite good fun. So here's the first one. Can you stare at the centre of this elephant image? There's a rotating cross. Can you see it? If you stare directly at the centre of the rotating cross, not the left or the right of it, but the dead centre of that rotating cross, what will happen is that parts of your eye will get fed up with seeing stuff, and so they'll actually sort of switch off. They'll become numb to those colours. And when I switch off the image, like that, blink a couple of times, can you still see the elephant? It kind of follows your eyes around as well. I'm still seeing it. For me, what colour is it for you? Yep, oh, it's gone now. Right, now the colour that you see tells you something about how your colour vision system works, and scientists use this colour to do experiments on how we see colour. Here's another experiment. This is really quite a really weird one. We've got an image here. You can print this out. If you see the name of it, the Adelson checker chart, you can print this out on a bit of paper and it works just as well. Look at the area labelled A and the area labelled B. Do they look identical? The squares, do they look identical to you or not? to me, they look extremely different. I would say that A is quite dark and B is quite light, but make up your own mind. Right, so what I could do is I could get a measurement machine and I could measure those colours. But what I would get from my colour measuring machine would be very different to what you're saying you see. Because actually, those two colours are identical. What? I hear you think. Let's introduce this mask. Here's a mask. It's got two holes in it, and I'm going to move it across. Can you see that the grey is the same as the grey of one of those squares already because it's overlapping? But when I'm going to move it across, the holes. Can you see the holes? You can see the lettering through some part of it. Will cover over those squares. Here we go. And suddenly you can see they are identical. That is so weird, isn't it? So the areas A and B are absolutely identical in lightness, and yet we didn't see it that way, did we? Well, I didn't. Any idea why? So there are actually three reasons why people see these differently. The first is that B is apparently in a shadow, and things in shadows look lighter than they really are. It's just the way our brains work. Also, B is surrounded by dark stuff and A is surrounded by light things. So the things that are around other colours affect the way we see them. So B, because it's surrounded by dark stuff, looks lighter than it really is. And A is surrounded by light stuff and it looks darker than it really is, just because of the colours that are around it. We don't see things in isolation just by themselves. And finally, this is the third reason, and this is the weirdest, and to me the scariest. You recognise the pattern. You know that B is a light thing and you know that A is a dark thing because you've seen a checkerboard before and you know the sequence, you know the shapes. So what's happening here is that what you think you are seeing is actually telling your brain what you are seeing. That seems quite spooky to me. But that's the way the human brain works when it sees stuff. And if I wanted a machine to see colours the way that people did, I would have to tell it to take into account what is around it, to take into account whether it appears to be in a shadow, and to also take into account, when I'm doing that measurement of the colour, of the fact that there might be a pattern involved, which makes measuring really, really hard. I didn't say my job was easy, did I? I haven't got anything else to tell you about my job. If you enjoy doing science, I certainly do, have a go at some of our measurement at home challenges. I did these just for fun. You can log on and you can play with these things and have fun being a scientist. You don't need to prepare lots of stuff in advance. You need to gather a few bits and pieces that they'll all be in your house. Don't need to do it at school, and useful if an adult sits around to help you as well. But and then you enter the information and we all share it and it's great fun. So right, I'm going to stop there. Thank you very much for listening.